one good day in Algebra, we're covering CO33, determining if two lines are parallel, perpendicular, or neither. And we're going to start by kind of defining what parallel and perpendicular lines are. So no doubt you've heard of parallel lines. What are they? What is their definition? Blake? Lines that never intersect. Okay, lines that never intersect. It might look like this, right? And who can tell me, kind of take that extra step and apply it to what we're talking about in this unit here, graphs and lines and all that stuff. Why won't they intersect? What characteristic would those two lines have to have in common that would ensure they never intersect? Exactly. Two lines that are parallel will have the same slope, right? Because remember what slope does. It describes how a line moves across the coordinate plane. If two lines move at the same rate, they're never going to cross, right? It's just like, how old are you folks? 12, 13 years old? Something like that? 13? I'm 36, okay? And we will always stay 23 years apart, right? Even though I'm aging, you're aging, we'll always say the exact same age apart because time moves at the same rate for all of us. You know, if you plant two trees, one is 1 foot taller than the other one. If they grow at the same rate, well, that shorter tree is never going to catch up to the taller one, right? Because they're growing at the same rate. That they'll always be 1 foot apart. Same idea here, okay? Lines with the same slope will never intersect because they're moving the same way. How about perpendicular lines? We'll come back to these examples here in just a little bit. But what about perpendicular lines? What are those, Peter? Lines that intersect, but they intersect in a special way. It's more than just that they cross. Yes, lines that intersect at a 90-degree angle. Okay. That would be an example of perpendicular lines. One is, in this example, one is horizontal, one is vertical, and they got that right angle there where they intersect. Okay. If you look around the room here at my bulletin boards, right, the top and right side of bulletin board, those would be segments that intersect at a perpendicular relationship, okay, that right angle. So when we say that lines are parallel, perpendicular, or neither, that neither group would just be lines that intersect, but not at a right angle. Because either lines won't intersect or they will. Okay. If they don't intersect, they're parallel. If they intersect at a 90-degree angle, they're perpendicular. If they intersect any other way, such as that or this or whatever, okay, that's the neither group. They intersect, but not at a 90-degree angle. What can you tell me about the slopes of perpendicular lines? What causes them to intersect perpendicularly? Any thoughts? Adam?
Maybe the numbers on the two slopes are just flipped.
Okay, so flipping's part of it. Okay, Adam said the numbers on the two slopes are just flipped. That is a part of it. If two lines that are parallel have the same slope, you can think about lines that are perpendicular have the opposite slope. And by opposite slope, not only are the numbers flipped, but the sign changes as well. Okay, and we call that two lines that will have a negative reciprocal slope. Negative reciprocal slope. Okay, the negative means the sign changes, and reciprocal, you probably have heard that word with fractions before, means the fraction flips. So going back to parallel lines for a bit here, if line A has a slope of 2/3, a line parallel to it will have a slope of 2/3. Okay? If a perpendicular line, right, if line A of a perpendicular relationship has a slope of 2/3, the slope of line B, perpendicular to it, will be, Violet? -3/2. Good. The sign changed and the fraction flipped. That's what's going to get that 90-degree angle. If line A, back to parallel now, if line A has a slope of -9, quite steep. Line A has a slope of -9, a line parallel to it will have a slope of -9. Okay. If line A has a slope of -9, a line perpendicular to that, Joe? +1/9, exactly. The sign changes from negative to positive. The fraction flips. If you flip 9 or 9/1, you get 1/9. Questions so far? Would this have helped on the map test? We should have taken it at the end of the day today. All right, so there you go. Okay, so let's practice a little bit here. Determine if line A and line B are parallel, perpendicular, or neither, and explain. To start, I just give you both lines in slope-intercept form. So this first one, line A, y is equal to 4x plus 3. Line B, y is equal to -4x plus 7. Raise your hand if you think it is parallel. Parallel lines. Anybody? Any takers for parallel lines? Same slope? No. Ooh, 1. Way to be different. Wrong, but different. Raise your hand if you think the lines are perpendicular. Couple hands up. Okay, raise your hand if you think they are neither. All right, they are neither. And the reason why they are not parallel, because 4, what we're looking for here, 4, is not the same as -4, right? They're not perpendicular, because even though we've got the opposite sign, we don't have that reciprocal part, right? A slope perpendicular to +4 would be -1/4, not -4. So this one, neither. Okay. Next one, line A, y equals 2/3 x minus 4. Line B, y equals 2/3 x plus 7. Raise your hand if you think they are parallel. Raise both hands in a parallel fashion. There you go. Raise your hand if you think they're perpendicular. No, neither. They are parallel. Okay. 2/3 is the same as 2/3, same slope. They move across the corner plane in the same way. Okay, up 2/3, up 2/3, up 2/3, they'll never intersect. Notice we don't really care about the y-intercept piece here, right? We're only focusing on that slope. And finally, the last one, y equals -3x plus 8. Line B, y equals 1/3 x plus 14. Raise your hand for parallel. Perpendicular. We're catching on. Yes, they are perpendicular, because that -3 and +1/3, they are negative reciprocals of each other. The second row here, I give you the lines in standard form because that's what I do. Okay, so the extra step here is to convert to slope-intercept form first, so then you can identify what the slope is. So pick one of these you'd like to do. I have my guess as to what you'll say, but I'll give you the opportunity. Morgan? Of course, the last one. Okay, so the last one here. Line A is 12x plus 7y equals 14. So we're going to focus on line A right here. Okay, and we are going to convert this to slope-intercept form. If you need to review this, you can look back at PO24. That's where we first converted to slope-intercept form. And we did this a little bit in CO32 also when we graphed inequalities. But basically, we want to move our x term over to the other side by opposite operations. Subtract 12x from the right side. That leaves us with 7y equals negative 12x plus 14. Remember, can't combine 12x and 14. They're not like terms. Okay. Put that negative 12x in front because that's going to represent what our slope is because it's got the x there. And then dividing everything by 7 gives us a final equation of y equals negative 12/7. Ugh, what a nasty fraction, but we don't really care. Right? It's a slope. Fractions are okay. Negative 12/7 x plus 2. Now we look at line B. And we got 20x plus 14y equals negative 4x minus 42. Is this in any kind of form? Slope-intercept form, standard form, point slope form, anything? No, it isn't. But our goal is still going to be the same, right? We want to get that y variable by itself on that left side. So we're still going to move those 20x's over to the right side. The only difference is we already have negative 4x's there. So when we subtract our 20x's from the left and subtract our 20x's from the right, we actually do get to combine them with something. There's already negative 4x's over there, right? So we get 14y on the left side. Negative 4 minus 20 is a negative 24x, and then minus 42. How's this looking so far for parallelness, perpendicularness, or neitherness? Our last step is to divide by 14. I shouldn't say our last step. Our next step is to divide everything by 14. On the left side, we got y by itself. And we got negative 24/14. Negative 24/14. What can we do with negative 24/14? Do we care it's a fraction? No. But it is a fraction, so SEPA, we need to simplify it. And what does negative 24/14 simplify to be, Joey? It simplifies to be negative 12/7. And then negative 42 divided by 14 gives us negative 6. Nope, that's not right. Negative 3. Okay. So you got to be careful with these. Those folks that like to get through things as quickly as possible, maybe not, show work all the way through. They tend to miss things such as this because they see that negative 12/7, and then they see, oh, I'm dividing negative 24 by 14. That's not the same. It's got to be neither. But in fact, negative 24/14 does simplify to be the same value as negative 12/7. So these lines are indeed parallel. Okay? Work through the question until its completion and simplify your fractions. All right. Good? Okay? Questions on what I just did there? You can do the other two on your own for homework practice, but questions on what I did? No? Okay. The second page. More of the same. We've got line A and line B. This time I give you two ordered pairs that each line passes through. So raise your hand and tell me, what is your procedure for this? What are you going to be doing, James?
First, you want to find the slope.
Using what?
So you subtract y1 minus y2.
Right, we got this handy-dandy slope formula here, all the way back to PO22. Find the slope of each line, and then do we need to find the y-intercept, or do we need to write the equation in slope-intercept form? Or is the slope really all we need? Slope is all we need, right? So in this first one for line A, we're going to subtract our y values, 6 minus 7 over 3 minus 2. And that gives us -1 over 1. Then in line B, we're going to subtract -7 minus 4 and 5 minus -6, or 5 plus 6. And that gives us -11 over 11. And that's all we need, right? All we need to look for here is the slope. Parallel, perpendicular, or neither? Oregon?
Neither.
Why neither? Just because they look neither?
Oh, it's parallel?
Why parallel?
Because they both equal 1.
They both equal -1, right? Yeah, they both equal the same thing. That line B slope, -11 over 11, again, if you simplify that fraction, it simplifies to -1 over 1, making these lines parallel, okay? So that's kind of what you're doing for those three there, just comparing those slopes using the slope formula. Then the brain busters, the bottom of the page here, it says, write the equations of two parallel lines in slope-intercept form. Raise your hand, someone give me an equation in slope-intercept form. Don't care what the numbers are, an equation in slope-intercept form. Caleb.
Y equals 2 over 3
Minus 2, okay? Someone give me the equation of a line that's parallel to that one in slope-intercept form. Blake. Okay. So this first part of this, you can really just make up anything you want to, right? As long as the lines are parallel, as long as they have the same slope, that's what we're looking at. Okay? It says now write the equations in standard form, which maybe it would have behooved us to not use a fraction slope there, because in standard form, you might recall, there's that thing about not having fractions and we're gonna have to multiply. But that's okay. You know, that's quite all right. Actually, I'm gonna write the second one to the right of this one so we can, okay? What do we need to do to y equals 2/3 x minus 2 to put it in slope-intercept form? Or sorry, put it into standard form.
You multiply everything by the denominator.
Right, we want to eliminate that fraction first, okay? Which means we're going to multiply everything by the denominator of that fraction, which is 3. Everything on the right side, both terms, and the y on the left side. So that gives us 3y equals 2x minus 6. Okay? I'll eliminate that fraction first. This goes back to, I think, CO23 / PO24. I think we covered in kind of both of them there, going from slope-intercept to standard form. What's our second step to get into standard form? We've eliminated the fraction. Now we got to get, yeah? Right. We want to move the x term over using opposite operations. So our final answer, -2x plus 3y equals -6. Okay. And then you'll do this something similar to the second equation. Multiply both by 3 and move your x's over there. Okay. And then you have to do the same thing with two lines that are perpendicular. You're going to write them in slope-intercept form and then rewrite them in standard form. All right. Questions, comments, concerns, complaints, comments, congratulations, or criticisms? Still snowing? Ugh.
Yes.
Peter.
Why are those two questions brain busters? They don't bust my brain at all. I seem easy.
Well, good. That is a testament to my teaching and your learning. No, Historically, the conversion from standard form to slope-intercept form has been challenging. Just kind of remember how to do it, and so let's also think of it in a different way too. You are writing the equations yourselves. You can set them up to make your work a little bit easier, or slightly more challenging, like we did here. But that's okay. Okay, no Google quiz for this one. This is your homework, the first and second page of CO33. It's actually not going to be due until Monday because tomorrow, actually Tuesday, oh my goodness, Tuesday, tomorrow is a retake day and Monday we are off of school. After 33, we've got PO34 to do and then the unit's done. So I anticipate covering PO34 on Tuesday and Wednesday. Which gives us a test to wrap up the week next week. So, okay, all right, that's how you math.
Don't forget to like and subscribe.